If we launched a rocket to Mars this decade, we could probably get it there. The problem is the people inside. Everyone thinks the hard part is building a rocket big enough. It's not. We already did that with Saturn V and Starship-class rockets. The real problem is space itself, how it attacks the human body for years at a time in ways we still can't fix. So the real Mars question isn't, can we get there? It's, can our bodies, our minds, and our systems survive the trip? On Earth, the atmosphere and magnetic field protect you from most cosmic radiation. In deep space on the way to Mars, that shield is gone. A Mars mission is roughly 3 years round trip. That's like giving astronauts a low-dose, full-body CT scan over and over for the entire mission. NASA classifies space radiation as a red risk. High chance, high impact, raising cancer risk, damaging the heart, and even impairing brain function. We could add heavy shielding or water tanks around the crew, but that adds mass, and every extra kilogram is brutally expensive to launch. A realistic Mars mission is around 3 years. In microgravity that long, astronauts lose bone and muscle at alarming rates. Models suggest that on a 3-year Mars mission, many astronauts could come home with osteopenia or even osteoporosis in critical bones. On the space station, crews exercise about 2 hours a day to fight bone and muscle loss, and that's for 6 months, not 3 years. Even when you arrive, Mars gravity is only about 38% of Earth's. That's not enough to magically fix your bones and muscles. Now imagine being trapped in a small metal tube with the same 3 or 4 people for months out, months back, plus time on Mars. At Mars distance, a radio message can take up to 22 minutes one way. You can't call Houston and get an instant answer. That delay plus confinement raises real risks: depression, conflict, burnout, even dangerous mistakes when you're months from any rescue. On Earth, a serious medical emergency goes to the hospital. On Mars, there is no hospital, and you are 100 million miles from home. Many drugs break down over years in space. Meanwhile, radiation and microgravity can change how your body responds to those drugs. Right now, space food is mostly shelf-stable pouches. For Mars, that means years without fresh fruits and vegetables. Bad news for both body and mind. We could go with today's rockets, but slower trips mean more radiation, more bone loss, more isolation. Faster propulsion could shrink all of those risks. So when you hear humans on Mars in the 2030s, remember, we're not just waiting for a rocket. We're racing biology, psychology, and physics. The good news? NASA and others are already testing radiation shielding, artificial gravity, Mars habitats, and long isolation missions here on Earth. We'll go when a trip to Mars is not just survivable, but sustainable. Until then, every experiment on the International Space Station and in labs gets us one step closer. Do like and subscribe so that you never miss an update.